Hi everyone, we're going to suppose an angle in standard position whose terminals, we're going to suppose an angle, theta, lies, that's in standard position, lies in a given quadrant. And we're going to find the values of the 5 remaining trigonomic functions. And basically to do this, we need our x, our y, and our r. Okay, so in this case, they give you cosine. So we know that cosine equals x over r. So my x is negative 12, and my r equals 13. Now this is a triple. You should know your Pythagorean triples, which is 5, 12, 13. So that means my y is 5. Or you can, use the r formula. So all we have to do is fill everything in. We know that sine of theta is y over r, which is 5 over 13. And then I'm going to go ahead and put the cosine here. So therefore, tan of theta equals negative 5/12. And then you just flip everything. Cosecant, do the reciprocals. 13 over 5. Secant of theta is negative 13 over 12. And cotan of theta is negative 12 over 5. Okay, the next one is, it gives us cosecant of theta is 2, and our angle belongs, you write a C in a line, this is an inclusion sign, belongs to quadrant 2. Don't write this as an E, it's not an E. Okay, so this is in quadrant 2. Let me put a Q there. Alright, so we know in quadrant 2 that's going to tell us a lot. So we know that, I want to put this in fraction form. So we know that cosecant goes with sine. So this is R, and sine is with y. So I have my y, I have my r, and we're in quadrant 2, so I know in quadrant 2 my x is negative. So all I have to do now is solve for my x. And the way we're going to do this is we know that r squared equals x squared plus y squared. So we have 2 squared equals x squared plus y squared. So I'm going to subtract the 1 equals x squared. So I know 3 equals x squared. Now when you square root both sides, don't forget to put the plus and minus. So x is plus or minus square root of 3. Now we're going to take the minus because we're in quadrant 2. So it's minus square root of 3. Then you just fill everything in. We have sine of theta. It's just going to be 1/2, which is your y over your r. And your cosine of theta is going to be negative square root of 3 over 2. And your tan of theta is negative 1 over square root of 3, which is just your y over x. And we know that equals negative square root of 3 over 3. And now, you can hear my cats in the background. So cosecant of theta, we already know is 2. Secant of theta is negative 2 over square root of 3. And for cotan of theta, I'm just going to flip this one, which is negative square root of 3. The only thing we have to do is clean that up. Negative 2 over square root of 3. I'm going to rationalize the denominator, which is negative 2 square root of 3 over 3. Okay, the next one we have is Sine of theta equals negative 1 over 5, and our angle belongs, so put a C in a line, to quadrant 4. So I know in quadrant 4 my x is positive and my y is negative. So when you set this up, y over r. So my y is negative 1 and my r equals 5. R is always positive. So we're going to do r squared equals x squared plus y squared. And my r, I'm going to go ahead and change this, sorry. My r is 5 squared. And subtract, we get 25 minus 1 equals x squared. So x squared equals 24. Square root both sides. Don't forget your plus and minus. So x equals, this is 4 times 6, so this is plus or minus 2 square root of 6. Since we're in quadrant 4, x is positive, so we're going to take the positive. So it's going to be 2 square root of 6. And this looks funny. It's negative 1. So we have our sine. We need our, I'll go ahead and write it again. Cosine is your x over r. And tan is your y over x. And then do the reciprocal. Cosecant, it'll be negative 5. Secant of theta equals 5 over 2 square root of 6. And tan of theta equals negative 2 square root of 6. So I have to clean this these two up. So I'm going to rationalize it. Negative 1 over 2 square root of 6. That's negative square root of 6 over 12. And this one, I'll do that one. That's going to be 5 square root of 6 over 12 as well. So it's kind of sloppy, but there's your two answers here. All right, let's just do one more. Let's do, let's see, tan. We might do 2. Tan of theta equals 2. And we are in quadrant 1. So basically, this is over 1. So this is your y and your x. So we have our y and our x. Our x is 1. Our y is 2. Everything's positive in quadrant 1. So our r is just square root of 1 squared plus 2 squared. R is always positive, so r is the square root of 5. Now, fill everything out. So we have sine of theta equals y over square root of 5. So this is 2 square root of 5 over 5. Cosine of theta is 1 over square root of 5, which just equals square root of 5 over 5. And tan, we already know that one. And then just flip everything. Again, I'm just going to flip that. So we're going to get cosecant of theta equals square root of 5 over 2. Secant of theta is going to be square root of 5 over 1. And tan of theta is 1/2. And I'm going to try to see if we want to do one more. I want to go ahead and do one more. we have cotan of theta equals 1. So that means this is y over x, or no, x over y. So that's x over y. So my x is 1, my y is 1. Therefore, r is going to be square root of 2. I'll let you figure that one out and then fill everything out. We already know that tan and cotan are the same. 1 over 1, you just flip it. And so I picked an easy one. Cosecant of theta is square root of 2, and secant of theta is square root of 2, and therefore cotan equals 1. Okay, that's all. Thank you and have a nice day. Bye-bye.